So today we're going to be taking a look at something called compound interest. And just as a reminder that interest is money earned on a loan or on an investment. So banks will charge you interest if you borrow money from them. Credit card companies will charge you money if you borrow from them, which is also interest. And there's two different types. Last year we did simple interest, which is based on everything being done for 1 year. Compound interest is where you get interest added back in more than once a year, usually. So notice this formula, not given on the final exam, so you have to memorize it. And it's very similar to what we did with our regular increase or decrease formula, if you remember from yesterday, was A equals P, 1 plus or 1 minus R to the T power. The only difference is now we have this N. All right, well, let's talk about it. A is the current amount. P is your principal, right? That's the money that you've invested or borrowed, depending on what the situation is. R is still the interest rate as a decimal. T is still time in years. But this is the new part. It's the number of times the interest is compounded each year. How many times a year are they paying you the interest? Annually is 1. Monthly means 12, right? Because you're getting it once a month, 12 months in a year. Quarterly is 4. Those are the most common ones. All right, so let's see how this works. Maria's parents invested $14,000 at 6% per year compounded monthly. How much money will there be in the account after 10 years? So the things we need to know P, which is the $14,000. We need to know R, what's the interest rate they're getting, which is 0.06, because we're going to take that percent and write it as a decimal. We need to know T, which is 10 years. And then we need to know this N. How many times are they going to get it? They're getting it monthly. Monthly means 12. So now it's just a matter of plugging all that into your formula and putting it in your calculator. So we're going to start with our formula. 1 plus R over N to the NT. So P is our $14,000. R is 0.06 divided by 12. And then this is 12 times 10. So you can do this all in one big formula, but you have to in your calculator, but you have to be very careful how you're doing it. So I was able to put that in, and this is implied rounding because we're talking about money. So we would have $25,471.55. If you're trying to put this in your calculator and you're not getting that money, then I would go through and do it step by step. Take care of your parentheses first, and then do the exponent, then times the $14,000. There's nothing that says you have to always do it in one big step. All right, let's try another one. So Paige invested $12,000 in an interest rate of 5.75% compounded quarterly. Determine the value of her investment in 7 years. So again, I have to go through and figure out, well, what are they telling me? What am I looking for? Right? So P is the amount that's being invested, $1,200. R, 0.0575, that's your interest rate. T is 7 years. This time it's quarterly, which means it's 4. Okay, so in my formula, A equals P times 1 plus R over N to the NT. So $1,200, 1 plus 0.0575 over 4 to the 4 times 7. So again, I was able to put that in my calculator. So after 7 years, she would have $1,789.54. If you need to do that step by step, please do so. All right, another example. So Jim's investment of $4,500 has been losing its value, right? Losing its value, which means instead of doing a 1 plus in our formula, we're going to have to do 1 minus. Right? At the rate of 2.5% each year, what will his investment be worth in 5 years? So I still have to know all my parts, right? I have to know A, which is what we're looking for, P is how much he put in, $4,500. R is the rate that he's losing it, 0.025. T is 5 years, and N is 1, because each year means annually. I can't spell that, so we're not even going to try. Okay, so when I go and put this into my formula, so we have $4,500. I'm sorry, I'm going to start with my formula. So this time, though, we're doing 1 minus R over N to the NT. Okay, so unfortunately, you can work the same way. So R was 0.025, N is 1, and then 1 times 5. So when it's annually, it's really just a percent increase or decrease, like we were working on before. But after 5 years, his investment is now only going to be worth $3,964.93. Okay, suppose an investment of $5,000 doubles every 12 years. How much is the investment worth after 36 years, after 48 years? There is no compounding, which means that I can just do my regular percent increase formula. But this one's a little bit different. First of all, if it's doubling, that means your R is 100%. When you double something, you're doing 100% of it, which means that's 1 as a decimal. My time, a little bit different because it's doing it every 12 years. So it's going to be looked at in 12-year chunks. So 12 years is really going to be 1 time unit. 24 years would be 2 time units. 36 years would be 3. And then 48 years would be 4 time units. So that's a little bit different as well. Now, could you certainly just go through and keep doubling this? Absolutely, but we'll take a look and just put it into our formula. So this is our regular formula where we have A equals P 1 plus R to the T. We're putting in 5,000, 1 plus 1, and for the 36, that's 3 time units. So that would be, right, I'm going to write this one out, 5,000 times 2 to the third. So after 36 years, it's going to be $40,000. And for the 48, same idea, but I have to put in 4 time units. So still our $5,000. I'm sure most of you in your head are like, why doesn't she just double from the 40,000? Which will certainly work. I'm going to fill in the 2, the 1 plus 1, and this time it's to the 4th. Which would make it, $80,000. Okay, so it's all about understanding how the formula works, being able to pick out the pieces of information and plug them in where they belong. Any questions? Bring them to class. Have a good night, guys.